So can you see the writing, the whiteboard?
These are the answers.
Okay. So so this is your, like, if that is your DNA that needs to be replicated. So um, so quickly I'll just show you the process. So if that is the origin of replication, will be somewhere at some point, right? So for instance, so if that is your origin of replication, like suppose this one is the replication of origin. So at this portion, the DNA will be separated, right? So and also note that. So that is like one strand will be 5 prime and the other one will be 3 prime. So this one is a 5 prime. So the other one will be 3 prime, right? So the opposite will be at the other point. So if this portion is your replication origin, so replication will start from this region of your DNA. So this one 5, this one 3. Let's give the a line to the replication origin just for your understanding, a hypothetical line. So two replication forks will be started from here, this position of your genome. Also, what will happen in the other side? Hmm. So what will be the coordinates in this side of the strands? So 5 and this This one will be 3. This one will be 5. So what will happen next? Like this is your like after the pre-replication complex, like the helicase. I haven't shown the helicase, but this is your replication origin, and the 2 replication fork. One is here, 1 replication fork. The other one is here. Also note that the direction, like the replication fork or the helicase, mainly determines the replication fork's direction. So So this direction will be the replication fork direction in this side, because we know that helicase can go which direction helicase can move. Can anyone tell me?
So 5 to 3.
5 prime to 3 prime.
Yes, yes, that's correct. Because of the 5 to 3 prime end movement, so you can see this rightward movement is 5 to 3 prime end here. Just if you consider this right side, the 5 to 3 prime end. So the helicase will be at 1 strand. So which strand? The strand, the direction is from 5 to 3 prime end. So the 5 to 3 prime end is this one at this side, but at the other side, the 5 to 3 prime end is this strand. So if I can draw, I'm just giving the direction of the movement. So if I can draw the helicase, so helicase will be at the 5 to 3 prime end strand. So this is 5 prime, the upper strand. So upper strand is 5 to 3 prime end. So this upper strand, the helicase will be at this strand. Other one, at the other replication fork will be at the other end of your parent DNA. So two helices here. The blue triangle is the helicase enzyme, and this one will unzip rightward, and this one will unzip leftward because it can move from 5 to 3' end direction. So so here, if you consider just one side of the replication part, one strand will be leading strand, the other one will be the lagging strand. So depending on the replication process or the continuous or depending on the continuous discontinuous process of the replication, one strand will be leading strand, because leading is like what is if something is at the front, and if something is at the back or lagging, that is called lagging. That's like behind. So the lagging strand will be behind, or the not actually behind in a real sense, but behind in the sense of replication process. Because in the leading strand, the replication will go fast, like there is no interruptions. And in the lagging strand, there will be fragments and discontinuous process. So the replication process is a bit slower comparing to the leading strand. So to the document will be the leading strand direction, and the lagging strand direction will be the opposite. So in the other side, there's two direction will be same, but we'll see that why there's two lagging strand and leading strand is opposite. Yes, you can see the leading strand is from, this will be 3 to 5' end, because we know that DNA polymerase can go in this direction. So can read the parent strand in this direction, 3 to 5' end. So in this direction, there will be no interruption in the DNA replication process. So as a result, this strand will be leading strand. In the lagging strands, there will be some interruptions. So the opposite direction will be the lagging strands. So on the right side, the leading strand will be the down one, because the direction of the lower one is 3 to 5 prime end. The direction of the upper strand is from the 5 prime to 3 prime end. So if we start by looking at the leading strand, the lower strand, because of its direction at 3 to 5 prime end, then what happens? Like at first, the priming will occur. That means the RNA primer or just primer or RNA molecule will attach, starting from this replication of origin. So suppose this is your primer, the green one. Primer has been attached by which enzyme? This enzyme, the enzyme,
DNA primase.
yes, DNA primase. This the attachment of this primer will be done by DNA primase. This is the first step after the formation of the replication fork. And then here will be a 3' O hydroxyl group free, that will be free, and then the DNA polymerase will synthesize the DNA or nucleotides from this direction. Synthesize has started by DNA polymerase. There will be hydrogen bonds here, ATPs, complementary. So synthesizing direction will be from which direction the synthesis will occur?
From 5 prime to
Sir,
3
5
prime.
to 3.
Right, 5 to 3. So yes, 5 to 3. Why? Because if that is, you have to consider the movement of the replication fork. So replication is moving rightward. So the rightward movement is here is from 5 to 3 prime end. So as a result of this, this one will be your 5 prime end, and this end of your new strand, right, of your daughter strand. And this will go rightward as along with the replication fork. So in the leading strand, so this is a leading strand. In the leading strand, there will be no problem, but there will be some problem in the lagging strand. So as you can see, if RNA primer binds here, then the DNA polymerase cannot go rightward because the direction will be rightward, will be the opposite of the DNA polymerase can go. So like if it starts from here, then it will have to go rightward, like so the direction will be from 5 to 3 prime end, so that will not be possible for DNA polymerase. So the direction of the synthesis, direction of the reading will have to be from 3 to 5 prime end. So if you consider 3 to 5 prime end movement, that is from right to leftward, because the right side is 3 prime end, the left side is 5 prime end. So like here, like primer has been attached, because unlike the other strand, the primer cannot be attached here because it cannot go rightward. So synthesizing will not be able to go rightward. So it has to be from the reading of the DNA polymerase has to be from 3 to 5 mm. So that is in this direction, in the right to leftward, in the upper strand or the lagging strand. And then the DNA polymerase will come and attach the new strand. So if that is a daughter strand, the 5 prime will be this side and 3 prime will be this side. That will be the synthesizing direction. The synthesizing direction will be opposite. Sorry. If we are telling here the synthesizing direction, then this one will be opposite. Sorry. So this is your strand. The red one is your new strand. So like this process also the same will occur. The DNA polymerase will come again at the other site and also synthesize a new strand. And then at some point this junction of the fragments, two fragments, will be uh, merged by a ligase, DNA ligase enzyme. So the direction will be 5, 2, 3. So these small fragments like this primase, primer on a small DNA strand, a small replicated DNA strand is called Okazaki fragments. Okazaki fragments are found in the lagging strand. So also note that I cannot show you the whole process because at some point, like after 5 minutes, this replication fork will go rightward, and there will be some empty spaces here in the lagging strand. Empty spaces because the DNA polymerase cannot go right side or cannot synthesize right side of the lagging strand, and then at some point there will be some empty spaces, and then the DNA polymerase can the primer will attach here, and the DNA polymerase will start in the leftward, and then again at some point the as the replication fork moves rightward, and there will be more empty spaces in the lagging strand, but in the leading strands there will be no empty spaces because as the replication fork will go, the leading strand will continuously go forward along with the helices enzyme of the replication fork. But this continuous is not possible in the lagging strand. So this is the mainly the replication at leading strand and the replication at the lagging strand. Also, the same scenario will be opposite in the other side because here the helicase binding strand will be always the lagging strand. So here the helicase was found in the lagging strand because it can move or read or it can break down. Or sorry, not break down. It can, yes, it can only break down from 5 prime to 3 prime end. So the strand that is from 5 prime to 3 prime end, that strand, helicase will be attached to that strand. So here the 5 prime to 3 prime end is the lower strand. So that is the 5 to 3 prime end. So the helicase is attached here. So the helicase will be the lagging strand, and also the other strand where the DNA polymerase can continuously go from 3 to 5 prime end. That will be the leading strand. So if you compare the right side and the left side, then the whole process is opposite because of the opposite direction. So the upper strand, the leading strand will be the lower one here. Sorry, the lagging strand will be the lower one here, and the upper one will be the leading strand. So I guess up to this point, uh, I'll upload the lecture, and if you follow the lecture, then I guess the whole process will be clear.